Hi guys, this is Group 11 and today we're going to discuss the topic about FCFS, or what we call the first come first serve in operating system. So this is a very self-explanatory which we always encounter anytime anywhere. Before, when the time that there's the COVID-19, I remember I was in a bus stations waiting for another bus to arrive, right? And there's like a line there to fall in line, then you're going to enter the bus one at a time. So that's how it works. So Rochelle, Postor will be explaining the definition of FCFS.
Hi, I'm Rochelle Postor. So, in first come, first serve scheduling algorithm, as the name suggests, the process which arrive first get executed first. Or we can say that the process which requests the CPU first get the CPU allocated first. First come, first serve is just like FIFO, or first in, first out, where the data elements which is added to the queue first is the one who leaves the queue first. It is easy to understand and implement programmatically using a queue data structure where a new process enters through the tail of the queue and the scheduler selects process from the head of the queue. A perfect real-life example of first come, first serve scheduling is buying a ticket at the ticket counter.
So yes, that's it for the definition. Now we're down to the characteristics of the FCFS, which will explain to us by Mr. Mark Opeda.
Characteristic of first come first serve. It supports non-preemptive and preemptive scheduling algorithm. So what is non-preemptive and preemptive scheduling algorithm? Non-preemptive scheduling is a CPU scheduling technique. The process takes the resource and holds till the process gets terminated or is pushed to the waiting stage. The process is interrupted until it's completed, and after that, the processor switches to another process. Preemptive scheduling. Preemptive scheduling is a CPU scheduling technique that works by dividing time slots of CPU to a given process. This scheduling is used when the process is ready to start. Jobs are always executed on the first come, first serve basis. It is easy to implement and use. This method is poor in performance and general time is quite high. Turnaround time and waiting time response time is high. Process with longest burst time can manipulate CPU, even if other process burst time is too short. Hence, throughput is low.
Alright, so like all things as well, the FCFS also have a advantage and disadvantage. And we're going to start to the advantage, which we're going to discuss to us by Mr. Nandin.
CPU scheduling involves many different scheduling algorithms which have their advantages and disadvantages. The one is the first come first serve, or FCFS. The advantage of FCFS is it is simple and easy to understand. And FCFS algorithm doesn't include complex logic and executes it one by one. Hence of FCFS pretty simple and easy to implement. Eventually, every process will get a chance to run so starvation doesn't appear.
Alright, thank you. So now we're down to the disadvantage to be explained by Ms. Charity Olegario.
Hi, I'm Charity Jaime Olegario, and I will be discussing the disadvantages of FCF scheduling algorithm. First, it is non-preemptive. Second, if if long period process came first, then all small processes should wait in the queue. It will increase the average waiting time. Third is FCFS is not an ideal technique for time sharing. Because of its simplicity, FCFS is not very efficient.
This also how to calculate the average waiting time and FCFS by Jason Monilla.
Hello guys, ngayon i-discuss ko kung paano makuha yung total average waiting time ng CPU first come first serve processes. So una lang titignan natin dito is yung arrival time at saka burst time. So para makuha natin yung value, gagawa tayo ng Gantt chart. As you can see, may Gantt chart tayo dito. Sa P1, since siya yung una nag-arrive, value niya is 0. Then yung burst time niya is 7. Then yung P2, siya yung pangalawa nag-arrive. Then yung burst time niya is 5. 7 plus 5 equals 12. Then si P3, siya yung pangatlong nag-arrive. Then yung burst time niya is 2. So 2 plus 12 equals 14. Then ganun din sa last na process. Then pag nakuha na natin yung value, pagpa-plusin natin lahat, then di-divide natin kung ano yung process. So divided by 4. Yun yung value.
So another explanation with Gantt chart by Mr. Perez.
FCFS, or first come first serve algorithm. It has 5 processes, which are process IDs: the P1, P2, P3, P4, and P5. And it has its arrival time, burst time. So the first one in this chart, on this Gantt chart, is P3. Why P3? P3 because it is the smallest arrival time, which is the 0. And the burst time is the completion time of the process. So P3, 0 is the arrival time, and then here is the burst time, which is 3. So indicated here is the shaded box represents the idle time of CPU. So this is the shaded box, the idle time or the sleep time of the CPU. So it is not used, or it's not processing. So we let's go to P1. So the arrival time of P1 is 4, and then the burst time is 5. So that's why 9 here, because in E plus 5, 4 plus 5 is 9. And then the third one is the P5, which is 5, and it has its burst time or completion time of 4. So 9 plus 4 is 30. Then next is P2, because P2, P2 and P4 has the same arrival time, has both 6 arrival time, but in this chart they say if two process ID has the same arrival time, so you will just depend on the process ID with the smallest process ID, which is the 2. So that's why 2 is the first, and then P4 is here in the last. So 13, we have here 13, P2 is arrival time of 6 and completion time of 4. So 13 plus 4 is 17. And the next is, we have the already 17 arrival time or burst time. So the next one is P4, which has a 2 burst time or completion time. So you just plus or added it in 17 plus 2, which is 9. So that is how you compute a Gantt chart. Thank you.
Alright, so we can also create a program that will compute that. So this will explain by Ms. Natania Rayos.
So we have a program here that implements the FCFS algorithm. So for this program, we will assume that all processes have the same arrival time, which means that their completion time and turnaround time is basically the same. So first, we need to consider
versus store processes their IDs. So we created an array here that stores their IDs and a variable here that stores their length. We also created an array which will store their respective first time. So we need to find the waiting time, and to do that we created a method called find waiting time. So we set the waiting time of the first process to 0 since it doesn't need to wait, and for the succeeding waiting time of the processes we just created a loop which will add its first time and their waiting time. So we have another method here to find the turnaround time called find turnaround time. So basically in this loop it will add the first time and the waiting time to find the current turnaround time of the process.
And lastly, here is Paul Ivan Pastor for a quick summary.
Good day, my name is Paulo Ivan G. Postor and I'm here to tell you about FCS or First Come First Serve method algorithm. What is First Come First Serve method? First Come First Serve method or FCS is an operating system scheduling algorithm which automatically executes queue requests and processes them in order of their arrival. It's also the easiest and simplest CPU scheduling algorithm. In this type of algorithm, processes which request the CPU first will get the CPU allocation first. This is managed with the FIFO queue or also known as first in, first out. The full form of FCS is first come, first serve. As the process enters the ready queue, its PCB or process control block is linked with the tail of the queue, and when the CPU becomes free, it should be assigned to the process at the beginning of the queue.
That's it for our topic, and I hope all of you learn a lot and enjoy the debate. So again, thank you for watching.